Good morning, everyone. My name is WenhaoWang, and I'm from Kobe University, Japan. I appreciate the opportunity to present my research today. The title of my paper is A Page Jump Recommendation Model and the Result Interpretation Based on Structured Annotation Method. This research is part of our ongoing work in the field of page recommendation, and my presentation will be structured as follows. Now let's move to the first part. And with the rapid development of online learning, researchers have not only noticed that students often reread the same page content, known as backtracking behavior, but also revealed a positive correlation between backtracking behavior and learning outcomes. In our research, we found that about 40% of page jump behavior occurs during the process of students looking for target pages, which leads to low efficiency in reading and learning. Therefore, the main work of this study is first, design a page recommendation system based on the per topic model, and second, to find factors affecting the accuracy of recommendations through the analysis of recommendation results, providing references for future research. Next is the second part on how to provide recommendations. We mainly consider two dimensions to provide page recommendations. The first is to mine the theme composition of each page from the content of the textbook and provide recommendations based on the similarity between pages. The second is to mine the relevance between pages from students' reading records to provide recommendations. For finding the similarity between pages, we introduce the per topic model. It mines the themes contained in the textbook and the theme composition of each page through processes such as word embedding, dimension reduction, and clustering. And this is the theme of the textbook, where each point represents a page in the book, and different colors represents different themes. And this is the theme composition of a page. Through this data, we can obtain the similarity between the pages of the entire textbook. For mining the relevance between pages from the records, we first define a few important concepts. Complete jump. A complete jump involves one or more page transitions by a student to locate the desired page for review. Jumping back and jumping forward. These are events when a student uses the previous or next button to jump from the current page to a previous or subsequent page. And short reading. After jumping to a page, the student typically reads it for a period to determine whether the page is the desired one. This helps determine the end of a complete jump. So when jumping back, jumping forward behavior occurs, if the time the student stays on the page meets the requirements of a complete jump, we consider that there is a connection between the action start page and the target page. The more complete jumps are mined from the records, the stronger the relevance between these two pages. Finally, by combining the similarity between pages and the relevance between pages mined from the records, we can provide jump recommendations for each page. Next are the results of this study. And the testing sets used to evaluate the recommendation mode's performance comes from 120 students who participated in the course in 2018. As shown in the table, overall, when only recommending one page, the performance of the recommendation system is excellent, being able to accurately recommend pages of interest to the user. However, as the number of recommended pages increases, the performance of the recommendation system declines very rapidly. For the second result, we found that the performance of the recommendation system varies significantly for different parts of the textbook. To explain the above results, we classify the students and the textbook content according to the students' reading time and the recorded complete jumps. We clustered the students and divided them into three types. Type A students have short reading time and fewer jumps, while Type C students have more jumps and longer reading times. For the textbook, we divided into 6 types based on its content. Type 1 and 2 are mainly related to concepts. Type 3 and 4 are mainly exercise problems. And Type 4 and 6 are unimportant parts such as cover pages. For result 1, this graph presents the analysis of the similarity between the jumping target page and the current page for each type of students. Here, when the similarity is higher than 0.95, we consider the two pages to be highly related, and when the similarity is lower than 0.5, we consider the two pages to be unrelated. It can be seen that there are significant differences in the similarity of the jump pages among different types of students. And this is the overlap between the jump pages of the three types of students, and it can be found that their overlap is all less than 0.5. This data indicate that different students have different needs behind their jumps, and the differences are large. And the recommendation system cannot cover all needs well, so the performance of the system declines rapidly as the number of recommended pages increases. For result 2, from the three paragraphs, it can be seen that there are fewer jump behaviors recorded between page 16 to page 100. Due to the lack of training data, the system has lower accuracy when generating recommendations for this part. However, from the right graph, the end section has more average words and requires longer reading time. For the process of finding complete jumps, the system should excavate more jump records. Therefore, we classified each part according to the content of the textbook and found that the end section has more concept comparisons and specific examples. And because it explains different concepts in detail, it reduces the need for students to find more information, thus reducing jump behaviors. Finally, here is a summary of this paper. For research question 1, the model accurately predicts the first choice of jump pages for 120 students, but more recommendations lead to a long tail effect. For research question 2, we analyze recommendations to understand the model's long tail effect and found that students' differences, diverse jump needs, and textbook content types contribute to the performance decline and the long tail effect. As for future work, we are using the recommendation system in actual classrooms, and in the future, we will add more dimensions of data to provide personalized recommendations. Thanks for your listening.